This presentation is on forest disturbance effects on snow and water yield in interior BC. The article was written by Rita Winkler, Dave Spittlehouse, Sarah Boone, and Barbara Zimmernick. It was published by IWA Publishing in 2015. This presentation was created by myself, Lucas, and Jed. Today we will discuss the objectives of this study, the methods used in this study, the results, and the impacts on the forestry industry. This study is about whether there is a significant change in snow accumulation and ablation with natural forest disturbance and clear-cut logging and the effects that has on spring discharge. The relationship between forest structure, snowy processes, and water yield are well understood in general, and this field study links stand to watershed scale hydrologic response to forest disturbance in snow-dominated regimes in BC. Coniferous forest canopy is well correlated with snow accumulation and ablation. These relationships vary with forest structure and condition, weather, elevation, and aspect.
Snow water equivalent was manually measured by removing cores from the snowpack, installing devices that lie flat on the ground, and weigh the snow as it accumulates on top. There's also gauges that weigh the incoming precipitation. Weather data was collected in both clear-cut and forested sites. Variables included radiation, air temperature, humidity, wind speed, and snowpack. Forest disturbance effects on snow and water yield were temperature at depth, snow surface temperature, snow depth, and rainfall. The study took place in two interior BC watersheds, Mason Lake and Upper Penticton Creek. Mason Creek is a lodgepole pine-dominated forest that is 50 kilometers north of Kamloops, while Upper Penticton Creek is located 26 kilometers north of Penticton and is dominated by Engelmann spruce and subalpine fir. Upper Penticton Creek measured 3 separate watersheds. Each watershed was roughly 5 kilometers squared with steep sloping terrain, gentle to steep sloping terrain. 240 and 241, as located on the map, are have southerly facing aspects, while 242 is westernly orientated. The elevation range ranges from 1,600 meters to 2,000 meters. Mason Lake was measured in 32 separate stations, all about in a 15-meter grid pattern. It has similar elevation as Upper Penticton Creek, around 2,000 meters.
This hydrograph shows peak discharge is much higher after 50% cut and minimum discharge is considerably lower than no logging. This is because the total accumulated discharge volume over the whole time period is very similar, only much higher and faster peak discharge events. Research shows a significant change in snow accumulation and ablation with forest disturbance and clear-cut logging, although the extent of change varies with location, elevation, aspect, and forest cover type. Naturally disturbed stands have been salvage logged or extensive areas of green forest in upland watersheds typical in interior BC have been clear-cut. Results show early snow melt and synchronization of melt runoff over a large area can advance the timing of spring high flows, significantly increasing April water yield and decrease yield in June and July.
The work being done at these sites helps the understanding of how riparian zones respond to natural and man-made forest disturbances. Evaluating hydraulic responses enables us to be able to predict detailed analysis of snowmelt contributions and response of logging extents. The results of the studies like this one will help us in the future for making decisions about stand retention, salvage logging, and flood assessments. Thank you for listening.